Have you ever wondered how important microcontrollers are to our lives? They are everywhere you can imagine, in our cars, in our homes, and also in our gadgets. But what would happen if they didn't exist? How difficult could our lives be? To answer this question, I was looking for a simple device to control without microcontroller, and I found this. The LCD display is one of the simplest devices to control. Many examples use it, especially with Arduino. So, let me summarize how to send characters to this LCD, using this table. The first 4 lines are used to set up the display. To simplify, we will use 8-bit data mode and only 1 line. Once the display is set up, we can send all characters to it. Note that during setup, the RS pin should be low, and it must be high when sending characters. Also note that the display will accept the commands only after a pulse is sent on the enable pin. We need to do this every time we send a command. So first, let's see how to do it with a conventional microcontroller. I'm using the famous PIC18F4520, and I developed this small piece of code to control the LCD using MPLAB. After compiling the firmware, let's see how to connect the LCD to the microcontroller. This is a typical circuit to connect the LCD to the microcontroller. Let's start the simulation to see the result. And there it is. Our characters are being sent to the LCD. Now let's see how to do it without the microcontroller. But first, let's go back to our table. Basically, we need to send an 8-bit data sequence and set some control pins. To explain it, I made this diagram. I'll use a memory to store the data and send it to the LCD in sequence. We'll also need a counter to select the data from memory in the correct sequence, and the clock will control each command, sent to both the counter and the LCD. Let's see how our circuit was made. First, let me show you our clock. I'm using the famous Astable 555 circuit to generate the pulses. Our memory is the 27C256, and the counter will be the CD4040. We also have the control unit, and I need to explain how it works to send the clock signal at the right time, first to the memory, and then to the display. I came up with this simple solution. We'll need a flip-flop and some logic gates. See how it alternate the clock to each other. This is necessary because first, our circuit will select the data from memory using the counter, and after that, it will send the selected data to the display using another clock signal. But there's another detail. As I mentioned, the first 4 lines of data are used to set up the LCD, and the RS pin needs to be at a low level. After those 4 lines, we'll start sending characters to the LCD, and the RS pin needs to be set high. Now, you may be wondering how to store the data in the memory. In this simulator, we can load it using a bin file, which is generated by a third-party program used to program EEPROM memory. As you can see the data on each address of the memory. Now, let's start the simulation and see the results. And our circuit without a microcontroller is complete. Notice how the logic sends each command in sequence to display all the characters. When the counter is reset, it all starts over. So, that's all for now. As you can see, a microcontroller simplifies tasks like this one. In this video, you saw how a complex logic circuit was needed to do something that a simple microcontroller could handle with ease. If you have any question, comment this video, and don't forget to subscribe.